All right, so the first video in the series started off with us looking at a quadratic equation that we were unable to solve by factoring. So what I had shown you is that there's this process called completing the square and taking square roots that allows you to solve those types of equations, those types of quadratic equations that are unfactorable. Um, the cool thing about this technique, as I had mentioned in the last video, is that it can be applied to any quadratic equation. So you can use the process of completing the square and taking square roots to solve any quadratic equation. And the nice thing is that we're going to take this process and we're going to turn it into a formula um, pretty soon. All right, probably within the next week or so. So let's talk about how to kind of put all of this together. The previous video, you practiced just completing the square on random expressions. So you basically took quadratic expressions, found a constant term that made that quadratic expression a perfect square trinomial. Now we're actually going to use that idea to help us solve equations. So let's take a look at this first one. Example number one is x squared minus 2x equals 3. So how do we do this? Well, what we want to do here is we want to add a number to both sides of this equation. And we want that number to make the left-hand side a perfect square. So this is really just what you did in the previous video. So remember, we need an x and an x here. And then we're going to take that middle term and cut it in half. It's going to be -1 and -1. So here we have x squared, -x, -x. And then this last constant value is going to be +1. So it looks like the number that we have to add to both sides is +1 to make this a perfect square. Now, the nice thing about using the area model is that our perfect square is already factored for us. Let me highlight the factors. So if you look, we have an x minus 1 and an x minus 1. So that quadratic trinomial on the left-hand side, which is x squared minus 2x plus 1, factors to x minus 1 all squared. And that's going to equal 3x plus 1, which is 4. So now what we can do is we can use the technique that we learned in the first video, or that we saw in the first video, which is taking the square root of both sides of this equation. So x minus 1 equals plus or minus the square root of 2. I'm sorry, the square root of 4, rather. Now, the square root of 4 is 2. So we get x minus 1 equals plus or minus 2. Then we're going to add 1 to both sides. So our solutions are x equals 1 plus 2 or x equals 1 minus 2. So 1 plus 2 is 3, or x equals 1 minus 2, which is -1. So the solutions to this equation are x equals 3 or x equals -1. Now, if you get nice whole number values like this, nice integer values, I should say, what that's telling you is that that original quadratic was actually factorable. Okay. But the nice thing is, as I had mentioned before, completing the square works for every single quadratic equation. So it'll allow you to solve any quadratic equation. And this kind of demonstrates that for you. All right, let's take a look at a couple more examples. All right. Screen keeps jumping around on me here. All right. So x squared plus 10x plus 8. Now, again, I always say try to factor first. If you can factor, that's a lot easier than going through this process of completing the square, in my opinion. Um, in this case, you can't factor this one, so we are going to have to actually complete the square. So let's go ahead and try that out right now. So the first thing that we want to do, leading coefficient is equal to 1 here, so we don't have to worry about dividing both sides by any number. But what we want to do is we want to move this constant term to the right-hand side of the equation and isolate the terms that contain variables. So x squared plus 10x, and I'm going to put plus some number equals -8 plus some number. So again, we're looking for a number that's going to make that left-hand side a perfect square. So a lot like the exercises that you did coming into this. So We need an x and an x for our factors. And then to get that middle term, 10x, we're going to need a 5 here and a 5 here. So x squared, 5x, 5x, and then 25. So the number that we need to complete the square is 25. So like I mentioned, some people say that the area model is, not as efficient, but the nice thing about it is that it gives you your factors when you're done. So x plus 5 all squared, which is just, I'll highlight the things that are equal to each other if you're not picking up on this. This right here and this right here, those are equivalent to each other, those expressions. Okay, and this is going to equal -8 plus 25, which is just positive 17. So just like in the previous example, square root both sides, and we get x plus 5 equals plus or minus the square root of 17. We're going to subtract 5 from both sides and get x equals -5 plus or minus the square root of 17. So again, this one clearly was not factorable. All right, so we go to the calculator now and get decimal. Actually, we could leave this if we wanted to have the exact answers, or we could get decimal approximations. I did that out. So I got x equals, let me write the actual answers, -5 plus the square root of 17, or x equals -5 minus the square root of 17. So we do those out. The answers are the decimal approximations. The first one is roughly -0.88. And then the other one is roughly -9.12. Now, one thing you can always do too is if you're not certain if the answer is correct, you can take and graph y equals x squared plus 10x plus 8 and look at the graph for the x-intercepts. And those x-intercepts should be equivalent to these two values right here. And if they're not, that means that you probably did something wrong or you entered in the equation incorrectly when you tried to check it. All right, one more example, and then you folks are going to be on your own to do some practice. Example 3 is 3x squared minus 24x plus 27 equals 0. Now, if you notice, example 3 is a little bit different than the previous two examples because it has a leading coefficient other than 1. In that case, what you want to do is divide by that leading coefficient. So you always, to start this process, want the leading coefficient to be equal to 1. So when we do this, we get x squared minus 8x plus 9 equals 0. Again, I always like to see if my trinomial factors nicely so I don't have to go through this process. It does not, so let's go ahead and complete the square. All right, so I'm going to isolate my terms that contain x. So I'm going to subtract 9 from both sides, and that's going to give us x squared minus x. Remember, I'm adding in, I'm sorry, let's take a step back there, minus 8x. Adding in a number that's going to complete this square or make the left-hand side a perfect square trinomial. And I have to add that same number to both sides to keep the balance in the equation. So let's go ahead and do that. We have x and x, and then -8 divided by 2 is -4. So we get x squared minus 4x minus 4x. We get 16. So it looks like we're adding 16 to both sides. So like I had mentioned before, the area model gives you your factors. So x minus 4 times x minus 4 is x minus 4 squared. Which again is just a factored form of x squared minus 8x plus 16. And that is going to equal -9 plus 16. So that would be positive 7. So again, square root both sides. X minus 4 equals plus or minus the square root of 7. We're going to add 4 to both sides. We're going to get x equals 4 plus or minus the square root of 7. Not 17, just 7. All right. So again, if we take decimal approximations of those results, x equals 4 plus root 7, or x equals 4 minus root 7. We're going to get x is approximately 8.12, or x is approximately negative 0.12. If you're having trouble locating the square root button on your calculator, that's something that you might want to look up on your user manual or on YouTube, just because it'd be hard for me to diagnose that remotely. Um, but this is pretty much the process. It is a bit tedious. The nice thing is that it always works. You're always going to be able to find the solutions to a quadratic equation by completing the square. What I will say is that, again, starting next week, we're going to take this process and we're going to turn it into a formula. And that formula is one of the most important ideas that you're going to learn in mathematics. All right, so good luck. I hope that you guys all do well with this. If you have any questions or concerns, feel free to email me or message me through Google Classroom, and we will see you in the next video.